Hey guys, welcome to Connecting the Dots, the podcast where we follow the breadcrumbs and try to predict where disruptions will take us. In this video and the next, I'll describe some less discussed but utterly brilliant aspects of Cybertruck engineering. This video will focus on some extremely exciting features, which I expect Cybertruck to have. And the next video will provide an engineering analysis of Cybertruck design gems. Elon said he expects the Cybertruck to be the best product ever. He also added, it'll be intentionally an insane technology bandwagon. So nothing in Cybertruck is conventional, and technology runs wild. There's a lot to unpack, and I can't wait to get started. But before everything, a special thank you to my Patreon supporters and YouTube members. Those are the people who make this channel possible. If you want to support the channel or buy me a coffee on PayPal, there are links in the video description. And if you enjoy my videos, please hit the like and subscribe buttons so I can grow the channel. YouTube's algorithm loves it when there are likes early on, so this helps the video reach more people. Thanks guys, and now buckle up and get ready, because the Cybertruck brings a truckload of disruptions, and disruptions are never boring. Cybertruck braking. Let's start with the braking, because Cybertruck's brakes should be like no other car or truck on the road today. Before I unpack this one, we need some context from a completely different topic, gigacastings. The gigapress is currently made by Idra and its parent company LK Technology, but it's not just some item that Tesla picked from their catalog. Far from it. Let's hear Elon tell how gigapress came to be.
What you're looking at are the biggest casting machines ever made, and it's kind of a crazy thing to make a car this way. It's never been done before. When we were trying to figure this out, there were 6 major casting manufacturers in the world. We called 6. 5 said no, 1 said maybe. I was like, that sounds like a yes. So, with a lot of effort and great ideas from the team, we've made the world's biggest casting machine work very efficiently to create and radically simplify the manufacturing of the car.
And now, there are rumors that Tesla is discussing the purchase of gigapresses from another supplier, the Swiss company Bühler. Tesla had a great idea, and they could have pursued it alone, but decided it would be better use of their engineering and managerial resources to just give the idea to one or more suppliers and have them make the product for Tesla, and then other companies down the road. Similarly, Tesla developed the 4680 battery cell, and here they did start producing it themselves. However, similar to gigapress, Tesla gave the idea to several of its suppliers so they could supply Tesla with better batteries than they did before. Tesla has many great suppliers, and when Tesla has a great idea that they want to pursue but prefer not to do it in-house, they have no problem to give it to their suppliers for free and help them make it. Of course, this means that Tesla's competitors will also get these parts sometime later, but Tesla doesn't care. All they want is to make the best possible cars first, and if other companies play follow the leader, so be it. By that time, Tesla will be even further down the road on its way to Mars. And I suspect the same thing happened with Cybertruck's brakes, where Tesla approached a supplier with a breakthrough idea and had them produce it. Tesla's supplier of choice in brakes is Brembo, which recently announced that next year they will launch a new type of brake system, unlike any other braking system available today. Announcements are cheap, and I've grown way past believing factory hype, but Brembo is right this time. In fact, industry experts consider this system, which Brembo calls Sensify, to be the biggest breakthrough in braking since anti-lock brakes appeared 40 years ago. To understand the breakthrough, let's first explain how regular brakes work. Virtually all cars nowadays have hydraulic brakes, and all use the same kind of system. The brake pedal is connected to a master cylinder, which by itself is connected to brake cylinders on all 4 wheels. When the pedal is pushed, this causes the master cylinder to push hydraulic fluid to the cylinders at the wheels. This fluid moves the cylinders to push brake calipers to clamp onto the brake discs, and this slows the wheels down. And with ABS systems, there are sensors in each wheel to check how fast the wheel is spinning. If a sensor detects that the wheel is beginning to lock, this sends a signal to the master cylinder to momentarily release the pressure. The master cylinder reduces pressure and then resumes it instantly, which gives the pulsating feeling in the pedal once ABS is engaged. Brembo's Sensify has several major breakthroughs, the first of which is that instead of a single master cylinder, each wheel gets its own small pressure-building cylinder. This is extremely effective in case a wheel locks under braking, as it enables the system to only release the locking wheel without lowering the braking pressure on other wheels. This shortens the braking distance, removes that bothering pulsating feel when ABS is engaged, and enables better control of the direction of which the car is heading under braking.
We have a pedal simulator in the front here, which is kind of like a traditional master cylinder. When you're pushing the pedal, you're pushing straight into a master cylinder, and then we have a spring pack that we can calibrate to give you a nice pedal feel. But the brake pressure is not actually going to the wheels like in a traditional system. Instead, we read the pedal stroke and then send a signal to our ECUs, which then create pressure requests that we create on the front calipers here.
Okay.
Now the way we do that is with electro-hydraulic actuators, and they basically have a little piston that pushes in and replicates what you would normally be doing, which is the master cylinder pushing pressure straight to the wheels. So it decouples the driver from the wheels, which allows us to do a little more control, and it also gives the driver a very, very consistent feedback from the pedal and a very comfortable feedback.
Excellent. Yeah, that's fascinating. So it's independently going to each wheel versus the typical mainstream where it's like all, yes, constant amongst them.
And that's a really good point. That's something that separates this from traditional braking systems, is there's actually 2 of those actuators here in the front. So each wheel is getting its own actuator, as opposed to having one box that's having to control all 4 wheels.
Excellent.
Yeah.
And I guess as far as like configurability and flexibility and like the vehicle design, it can also allow for some flexibility as well.
A lot. So now you've got these little parts to package instead of a big box, so you can put those in more creative places as opposed to having to find somewhere where a big box fits.
Absolutely. No, that so you're saying that versus like it's a lot smaller underneath, like visualizing a lot smaller than the typical system.
Absolutely.
Okay.
Far more compact.
The ability to control each wheel's braking force independently enables extreme control of the car. I expect all Teslas, including the Plaid Model S, to get these brakes down the road. However, as crazily fast as it is, the Cybertruck isn't a race car. So what makes me think that Cybertruck will have them? A few reasons. The main one is safety. Having independent control of each wheel's brake force makes the car much safer, especially in slippery and mixed grip surfaces that the Cybertruck might encounter. Tesla's most important design aspect is safety, and this should be double important with the Cybertruck. Accidents happen no matter what. And if a huge beast such as a Cybertruck or just a Ford F-Series truck hurls into other cars or road goers, the results could be catastrophic. Unlike the F-Series, however, the Cybertruck's accident would make headlines worldwide. So yeah, safety is critical. Another factor is Elon's touting that Cybertruck will be an insane technology bandwagon. And if such brakes exist with a Tesla supplier, I don't see Cybertruck not having them. Yet another hint is the timing, with Brembo saying the system will first appear on an undisclosed company's cars in 2023, the same year Cybertruck should appear. And of course, when Brembo demonstrated the system to reporters, they did so on a Model 3. The formal line was that they used it as reference because the Model 3 has excellent brakes. But come on, had their first customer been Mercedes or BMW, GM or Ford, Toyota or Nissan, do you really think they'd use Tesla, their nemesis, to show the system? I think not. Let's see how Sensify transformed Model 3's braking.
What we're going to do now is we're going to get up to 50 miles an hour, and then Zach, sitting in the passenger seat, the software engineer, is going to implement an emergency auto brake. So I'm going to take my feet off, and it's just going to brake for us. So we're going to, essentially see what it's like to fully brake with like no hesitation, no input. I mean, from myself, simply just the car, and it'd be kind of cool to experience. So we're going to go ahead and get up to 50 and let him do that. Yep.
3, 2, 1.
Whoa! That was crazy. Yeah, I knew that was coming, but then like you did it, and I was like, oh my god, yeah, that was crazy. It also happened so quick. Yeah, it was like a blur. Can we do it one more time?
Absolutely.
Okay, yeah. All right, here we go.
Yep. Yeah, if you want to go even a little faster.
Okay. All right. Well, yeah, we'll do like 55.
Yeah.
Man, that was like a roller coaster. All right, guys. So we're gonna get up to 55, and he's gonna again implement the auto emergency stop. So we are going. Okay.
3, 2, 1.
That's crazy. And it's just, again, it's like so, I mean, obviously it's abrupt that we're going from like 50 to 0 and like so quick, but it's still smooth to where I don't feel like I'm like totally like discombobulated and jarred. So Yeah, well done, Sensify. That's good. Again, like, it is like a comfort for sure. I feel comfortable, but also safe at the same time. So that's fascinating. So we're gonna go from 70 to 0, coming around the track now. All right, 3, 2, 1. Yeah, that's just super smooth. I mean, that was literally 70 to 0. So we're going 40 into this one. This one is like the tougher one, is a little bit of an obstacle avoidance. So we're gonna go up to 40. Yeah, crazy. Yeah, it's almost like, yeah, it felt very planted in the rear. When I hit that in the non-Sensify car, yeah, I felt the back end kind of come up. It was almost like I'm like kind of like on my tiptoes, kind of like hunching in. And this one I just felt very grounded, very planted from all angles of the car. It didn't feel like, I felt the pressure go to the front of the vehicle, the nose of it, but it wasn't like scared where I was gonna like kind of fishtail or feel like a hydroplane or anything like that. So again, we're hitting that 40 miles an hour on a wet condition. So that was cones that we were looking out for in that case. But you can imagine if you were doing that, like again, like I mentioned, dog running across the street, child, pedestrians, anything like that could definitely, you know, be like a life or death type scenario where in this case it would definitely save someone, just being able to brake that quickly and brake that smoothly.
We got steering angle at 45 degrees, then we're going to go into our software and say, okay, only give 75% braking force at first and then adjust.
Interesting.
And that's why you're not feeling that pitch forward of the car. That's your electronic brake distribution. Is we're actually looking at the scenario that we're in and saying, okay, wait, limit it at first, and then see where the vehicle's at before we put in too much force.
That's fascinating. That makes total sense, and from like a logical perspective of how you could. And the typical car is just like, nah, just slam on the brakes, you know, just lock them all up. We don't care what you're doing. So 40. That's nuts.
Here's what John McElroy of Autoline had to say about it.
Brembo has come up with a brand new kind of brake system that obsoletes everything that's on the road today. In time, I think, this new brake system is going to end up on every vehicle. But the new Brembo system, which they call Sensify, controls the braking at each wheel independently. And that's a whole new ballgame. The results were spectacular. Interestingly, Brembo used Tesla dual motor Model 3s for the test because Brembo says that car comes with one of the best braking systems available. It's quiet, smooth, and totally predictable. It makes an emergency slam on the brake stop feel like a normal braking maneuver. And it eliminates understeer because it can put more brake pressure on the outside wheels, something that today's braking system cannot do. Even in the wet, Sensify removes all the noise and pulsating distractions, and that makes it easier for the driver to focus on steering around any obstacle. And with electric vehicles, it maximizes the regen that you can get from each wheel. Brembo says it will go into production in 2024, but it will not say who the first car company will be to use it. But if I had to guess, I would guess it'd be Tesla.
There are several reasons I think Cybertruck will be the first to use this system, but there's more than that. Remember I said that Sensify has several breakthroughs, and that ditching the main cylinder and enabling independent control of each brake is just the first of them? The second breakthrough is that Sensify enables ditching all other cylinders as well, and replacing them with small motors to actuate each brake caliber.
This is really interesting because this is taking it even a step further. So not only is the driver decoupled, but you're in a situation where you have no hydraulic fluid in the back. They're electromechanical, and it's just a motor that pushes in a piston, and that puts the brake pressure on the wheel. So this is really good because now you're not running any hydraulic fluid, there's no bleeding process to do. We can integrate your parking brake directly into that system. Very compact, very easy to package, but then you still get the individual actuator control on every single wheel. So again, 2 controllers back here, 2 controllers up there. You're gonna get the best possible control and best feel out of the vehicle.
Absolutely.
No need anymore to route hydraulic lines along and across the car. No need anymore for hydraulic pumps, seals, cylinders, and connectors. Say goodbye to brake fluid, and no need to cool it and keep it from boiling. No need to routinely check the system for leaks. The best part is no part, and the best hydraulic system is no hydraulic system. All you need is to pull wires to each wheel and operate the brake's actuator. That's all. With Cybertruck's large dimensions, this means a lot. It saves a whole lot of weight, simplifies Cybertruck's already simple construction much more than before, and reduces cost by more than the new system's price hike. I definitely see Cybertruck having these, the best brakes in the world by far. The rear ramp. After these breakthrough brakes, let's cool down a bit with an amusing story regarding the rear ramp. Chances are you know more than I about the ramp, but I'd like to provide some context to help you appreciate how big a deal this ramp is. The true context for understanding the ramp is the Great Ladder War, staged between Ford and GM. Truck beds are high and hard to climb into. So in 2009, Ford introduced a new system it dubbed Stepgate. The system consisted of a hinged ladder step and a grab handle, which were integrated into the tailgate and used for climbing up. Let's see it in use.
Well, the way the tailgate step functions, it's very simple. You open your tailgate. Once the tailgate's open, you grab the tailgate step, you pull it up, pulls out, drops right down. Then we have here a handle, it pops up. All I did was I pulled this lever, pops right out into place. I grab this. This way I always have 2 points of contact. Works very easy getting in and out. Drops down the same way it came up. So all I'm going to do is pull this up, push it back down. From that point, I'll just lift it back up, slide it in. That is the tailgate step.
Simple, inexpensive, and very useful. I really applaud it. With its arch rival having this patent, for years all GM did was throw mud at Ford's system and that dinky grab handle that only girly Ford drivers have to use. After all, real men drive GMCs and Chevys and don't need that kind of stuff, right? They even went so far as to show paid commercials calling Ford's step a man's step, made to sound like a man's purse. Guys, I swear I'm not making this shit up. Here, watch this Silverado commercial yourself.
Hey, buddy, you left your little man step down.
Would you rather have a Ford F-150 with a man step or a Silverado that backs you for 100,000 miles or 5 years? Unbeatable coverage, unbeatable value. Chevy Silverado, America's best truck.
GM did offer a side bumper step on some of its models, such as this one, but it was a far cry from the utility of Ford's step. Then, in October 2016, GM finally snatched Ford's edge by filing 2 separate patents to copy Ford. The first patent, multi-panel hinged in-gate assembly with edge support for step panel, showed a step similar to Ford's, but instead of extending out of the tailgate, it broke out of it with an elaborate hinged mechanism. GM's second patent, dubbed tailgate assembly with a step assist handle, added to this tailgate a retractable handle similar to Ford's, to hold on to while climbing into or exiting out of the bed. It seems that suddenly grab handles weren't so girly anymore. GM launched the new tailgate step on the GMC Sierra and the Chevy Silverado, and the war escalated. Let's look at the tailgate in action. GM's system has some advantages, such as it's easier to climb, carries more weight, offers several operating modes, and can be ordered with a tailgate soundbar. On the other hand, it requires electrical actuators, is in my opinion complete overkill, and is sloppily done as it bashes onto trailer hitch balls. It's much more complicated than Ford's system, but I guess that isn't much of a drawback because, as you know,
complexity appeals to stupid people. That may seem harsh, but that's actually the case. Complexity appeals to stupid people.
Not to be left behind, Ford came up with its own patent for a stronger step, this time using the entire tailgate as a step versus GM using just the midsection. As far as I know, this hasn't reached production yet. So simple became complicated, and then even more complicated and heavier. But you still need to climb high to get into the bed, and still need to use rails or a ramp to haul up dirt bikes and ATVs, which is dangerous and could result in injury. Not to mention you have to buy the rails separately and carry them in the bed with you. And then comes this newbie Tesla and makes the truck kneel down low, so its rear bumper isn't much higher than the OEM's steps. And then they have the nerve to extend an integrated ramp from the tailgate to enable easy loading and unloading of ATVs and bikes. And to rub it in, they offer this tailgate free of charge with every Cybertruck version. To me, this seems that this newbie Tesla delivered a clear knockout to OEM engineering efforts. I'm sure some Chevy and GMC owners watching this might disagree and add that climbing the tailgate is just a tidbit and doesn't represent the company's engineering capacity. If that's what you think, I'll let GM do the answering for me.
What this tailgate really says about GMC is the ingenuity and the creativeness of the engineers behind it.
For once, I fully agree with GM. GM's complicated trailer hitch bashing upgrade of the simple step that Ford introduced 7 years before indeed says a lot about the ingenuity and creativeness of the engineers behind it. The engineers behind Tesla's tailgate crossed that low bar without even noticing it's there. Steer-by-wire. Back to the features. In most cars, including all current Teslas, the steering wheel is mechanically connected to the steering mechanism. The steering wheel is connected to a shaft, which goes forward and down, crosses the front firewall, and turns the steering rack. In steer-by-wire systems, this physical connection is removed. The steering wheel could be placed anywhere in the car, really. All it needs is a potentiometer to check what angle the wheel is turned, and a wire passing that angle to the steering mechanism. The steering mechanism takes care of changing the direction of the wheels and providing feedback to the driver. The system is usually power-assisted, and the power assist is provided either by hydraulics, like in the braking system example, or by motors. With Cybertruck, there's a lot more to it. But for now, let's just say that Cybertruck will arrive with steer-by-wire and electric power assist. Remember this point, as it will become extremely important later. So why do I think Cybertruck will have these two? The lazy thing is to reason by analogy. Many cars offer electric assist, and it's not like Tesla is the first manufacturer to offer steer-by-wire, as the Infiniti Q50 already offered it. In their case, it was poorly received, and they ended up recalling the vehicles. But time and technology progressed, and Tesla should do better. But others already offered it is no real reason, and the real reason for electric assist is efficiency. Just like the brakes example, it's much more efficient and energy-saving to use electric assist than hydraulic assist. And the real reason for steer-by-wire is that just like with brakes, it's cheaper to build than mechanical steering and significantly simplifies construction. Just like with brakes, no need anymore for hydraulic pumps, seals, cylinders, and connectors. Say goodbye to steering fluid and no need to cool it. No need to routinely check the system for leaks. The best part is no part. And the best hydraulic system is no hydraulic system. All you need is to pull wires to each motor and let it steer the wheel. That's all. But wait, there's more. In fact, there's a lot more. But first, let's just give a small side effect of having steer-by-wire in the car. If you or your kids like playing video games in your Tesla, prepare to get significantly upgraded because steer-by-wire enables using the yoke to play the games without having to turn the actual car's wheels. What's more, the small motor I expect the steering wheel to have to provide feedback and road feel could provide resistance and force feedback as you play the game. Nice, right? But that's the small stuff. As I said, there's a whole lot more, because Tesla's steer-by-wire will have its own unique flavor. In February 2019, Tesla filed a patent for a steering system for a vehicle. Basically, the patent describes a new kind of electric steering system which uses motors to steer the wheels. The patent describes the system and how efficient, inexpensive, simple to assemble, reliable, and space-saving it is compared to a hydraulic steering. All these we already discussed, but something else in the patent caught my eye. The present disclosure generally relates to a steering system for steering one or more steerable wheels of a vehicle. Does this mean what I think it does? And does this ring a bell? Of course, this is patent speak to cover every possible permutation. But with Cybertruck, I do suspect that just like with Brembo's Sensify braking, Cybertruck will include a separate steering motor for each of the four wheels. This opens huge possibilities, which we'll discuss in the following sections. The Cybertruck is extremely innovative and provides an outstanding alternative to regular trucks. Research shows that highly intelligent people constantly search for alternatives, which enable them to live a better life. This shows in their work and their hobbies, and is definitely true in investing. In fact, a groundbreaking Ernst & Young study last year revealed that 8 in 10 ultra-high net worth individuals invest in alternatives. And 40 years ago, the last time inflation was this high, one alternative in particular showed how powerful diversification can be: fine art. It had a whopping 33.2% appreciation due to its reputation as an inflation hedge, driving up demand, beating even gold. That's why Masterworks saw an opportunity to break open the market. So it wasn't just the 1% who had access. Their idea is simple. Just like you don't need to buy all of Tesla or all of Amazon to invest in these companies, you don't need to buy an entire Banksy or Picasso to invest in these paintings. Masterworks buys blue-chip paintings, securitizes them with the SEC, and enables us to buy shares in them. Investors can then trade shares in an active secondary market, or wait until Masterworks sells the painting. And they've produced some incredible results, delivering 25% net returns for the last 4 years in a row, through COVID, a bear market, and scathing inflation. Past performance is no guarantee of future results, but that's pretty incredible. Because I've partnered with Masterworks, you can click on the link in the description to skip the waitlist and get access to blue-chip art investing today. Variable ratio steering. When Tesla introduced the yoke on the Model S, the motoring press stayed lukewarm. But when Lexus showed their own yoke on the upcoming RZ, the press raved about it. Where the same publications blasted the yoke with Tesla, but hailed it with Lexus, Tesla fans called foul. But although we're used to being treated unfairly by the press, in this case at least, they were right. It wasn't that the Lexus yoke was better than Tesla's, it's that the RZ's steering is fit for a yoke, while Model S steering is more fit for a regular wheel. Cybertruck's steering will be much better, as I'll explain. The reason steering wheels are round is that when large steering angles are needed, such as while maneuvering in parking lots or doing tight turns, the steering wheel has to be turned several times around from its center position. Model S owners found ways to turn the yoke more easily than its rectangular shape suggests, but bottom line is that a round wheel would fall into hand much easier. Where the yoke does shine, however, is in highway driving. On a straight road with minor curves, the yoke falls neatly into hand, doesn't obstruct the forward display, and is more commanding than a wheel. Lexus solved that by offering steer-by-wire along with variable ratio steering. When going slow and with large turns of the yoke's angle produces large steering commands, so that parking lots and U-turns don't require hand-over-hand operation. But when going fast and with small yoke angles, the resulting steering commands are smaller, so that the steering doesn't feel too sensitive and jerky. This is the best of both worlds. In truth, variable ratio steering can be achieved even without steer-by-wire and electrical power assist, but having these two technologies makes it infinitely simpler to include. When I originally saw that Model S had the yoke, I expected it to have variable ratio. In fact, Elon himself said variable ratio would be better. However, since Model S and X kept the original model's mechanical steering linkage, Tesla decided to keep the steering ratio constant despite somewhat hurting the yoke experience. Cybertruck, however, is all new and intentionally an insane technology bandwagon, so expect to see variable ratio steering and an excellent yoke experience there. Rear wheel steering. Rear steering is far from new. The Hummer EV has it, as previously did various versions of the Ford F-150, Chevy Silverado, and GMC Sierra, and a wide variety of sedans and sports cars. Rear steering has many advantages, most of which are especially important for the Cybertruck. It makes the truck more stable in fast corners, but gives it a smaller turning radius in tight corners and parking lots. It provides faster and better steering response, with the truck quickly going where you want it to go with little delay. It works better on tough terrain such as dirt roads and snowy roads, especially when there's a sideways slope. It works better in straight line driving, especially when there are strong crosswinds or side slopes, and it makes lane changing easier. With so many advantages, not to mention an added advantage of not falling behind the Hummer in tech, clearly Tesla would want it. However, rear steering has downsides too, as these systems can add cost and complexity. That being said, Since Cybertruck should have electrically assisted steer-by-wire, there's no need to tunnel hydraulics or steering linkages to the rear, so adding rear steering would be inexpensive and simple. There are other upsides as well, which we'll discuss in the diamond steering section soon. But from what we discussed till now alone, with lots of positives and very few negatives, adding rear steering is a no-brainer. Torque vectoring. Like rear steering, torque vectoring isn't new and appears on many cars, mostly sports cars. Torque vectoring means sending a different amount of power to each wheel. This improves the car's grip when cornering quickly, in slippery conditions, and on rough terrain, such as the Cybertruck might encounter. This aids stability and safety and enables better acceleration.
So as you're coming into a corner, it's going to apply equal pressure to both rear tires, and that's basically to help stability as you're basically going in a straight line. Then once you start turning in, it's going to transfer more torque to the inside tire, and that's going to help rotate the vehicle. Then once you hit the apex, it's going to send more torque to the outside tire, and that's once again propelling you forward at this point in time, and that's done to maintain stability. And then as you come out of the corner and you're hard on the acceleration, then it's going to apply more on the outside in order to push you out of that corner.
There are different types of torque vectoring systems, some using the power, others controlling the brakes. With ICE cars, sending a different amount of power to each wheel requires using electronically controlled limited slip differentials. Although effective, this method is more expensive and is mostly used on sports cars and high-end performance sedans. Cheaper cars, such as hot hatches, often use a cheaper way of torque vectoring. Instead of controlling the power sent to each wheel, the system uses brakes to slow the tires it wants to go slower. Since regular open differentials send more power to the wheel that's less resisting, braking certain wheels also causes the car to send more power to the other ones. Multi-motor EVs, however, enable a third method for torque vectoring, which is to control the motors independently to supply different power to each wheel. In addition, the same motors could also be used to slow wheels down via regen. With all the hardware already in place, the cost of doing this is practically zero.
We can precisely adjust the torque output of each motor more than 100 times per second, in both directions, acceleration and braking. This enables us to use the maximum potential of this almost organic system.
With torque vectoring having so many benefits and increasing safety at zero added cost, adding torque vectoring is a true no-brainer, and the chances of Tesla not offering it are, in my opinion, small. I am almost certain that torque vectoring will be offered on the quad-motor Cybertruck, that it'll probably also be offered on the tri-motor, and that it will possibly also appear via brakes and regen in dual and single-motor versions. Diamond steering, crab walk, and tank turn. Since some of you might have skipped straight to this section, here's a quick recap of Cybertruck features important for this section. Cybertruck will offer a unique braking system with brake-by-wire, which should enable it to brake each wheel independently of the others. And it will offer a unique steering system with steer-by-wire, which should enable it to steer each wheel independently of the others. And the quad-motor version will offer a unique power delivery system, which should enable it to power each wheel independently of the others and provide torque vectoring. These unheard-of levels of independent wheel control make the truck safer and more agile. Doing so without requiring hydraulics also makes it lighter, more reliable, higher quality, cheaper to make, and simpler to assemble. However, using these systems also enables a whole lot of other things. Cybertruck should be an intentionally insane technology bandwagon, and these systems enable it to absolutely destroy its competitors' party tricks. Hummer EV's party trick is the crab walk, and with four-wheel steering, all versions of the Cybertruck will do that too. Easy. And Rivian's party trick is that they can tank turn, right? Not exactly, because in all truth, Rivians can't really do tank turns. Quad-motor Cybertrucks will do them. But before explaining what's different, let's dive into the truth in advertising regarding Rivian's tank turn. You might have wondered why YouTube is full of videos showing Hummer EVs doing crab walks on public streets, yet the only video of Rivian's tank turn available to date is that single video that Rivian itself provided when marketing the truck. The reason for that is that all Rivians delivered to date have been delivered without the crab walk feature, which is currently, quote-unquote, delayed. The official line is that the majority of Rivian's engineering resources are dedicated to getting the R1T, R1S, and Amazon van out the door, and after that, they'll have to work on the R2 and R3 models. As such, delivering an unessential party trick feature is low in their priorities list. That's the official line, but in truth, they have a whole lot of perfecting to do to make it deliverable. In fact, as I'll explain, the feature is almost unusable in Rivian's truck geometry. Stick with me, because this explanation will show why I suspect that Cybertruck will do things differently. Tank turns are based on the trucks, both Rivian and Cybertruck, having 4 motors, 1 for each wheel. To get the truck to turn clockwise, as in Rivian's demo video, both left side wheels turn forward, as we can see here, like they do in regular driving, while the wheels on the right drive in reverse, as clearly seen here. Since the forward power on the left side is balanced with equal reverse power on the right, the truck doesn't move forward or backward. But since each side tries moving in the opposite direction, the truck starts spinning around its center of mass. While cool in theory, and that is how tanks turn, there are several problems with this. The first of which is that the wheels are all pointing straight, but the spinning movement is in fact sideways. The only way to do this on paved roads is to spin the tires insanely fast so that they break traction, just like when doing donuts. So breaking traction is hard to achieve, and the only way to do tank turns is on low traction surfaces such as snow, ice, or in Rivian's example, a freshly watered field. And even on that field, breaking traction is possible only when spinning the wheels very fast, which results in extremely fast spinning, which might scare the driver and cause them to lose control, or just disorient them when exiting the turn. It's not by chance that Rivian's video is shown in slow motion, because even in these ideal conditions, the spinning is just too fast. Look carefully, however, and you'll see that a small snippet of their video somehow slid through in regular motion. Running this now in the background a few times, notice how scarily fast the rear goes sideways, and that's in ideal low traction conditions. To make things worse, Rivian trucks and SUVs are long and narrow, so their relatively narrow track gives the wheels a very short lever with which to cause the truck to spin. On the flip side, the truck's long wheelbase gives the sidewalls lots of lever with which to resist spinning. And flip side could be right, because although I don't have any info regarding this, and the Rivian's battery pack should make the center of gravity low, I wouldn't completely rule out the possibility of the truck toppling over, especially in presence of a side slope or hitting a rock. And even without that, if there is a slope in any direction, the truck wouldn't be able to contrast it, and unless the maneuver is aborted, it would just drift down the slope while spinning. And not all wheels break traction at the same time, which causes the truck to lunge erratically sideways when the truck is started, as seen in this part of the video. Similarly, traction changes along the turn, which also causes wheels to gain traction and cause the truck to lunge erratically. Rivian tried putting safeguards against these, but the bottom line is you need to spin the wheels way fast and get the truck spinning like an amusement park's scariest carousel to have a chance of completing the turn. The list goes on, but you get the picture. When Motor Trend queried Rivian about it, they wrote that what you see in the video was a best-case scenario, and the Rivian team was lucky enough to capture a good turn on the first try. Yeah, right. I beg to differ because looking at the state of the field in the video, it seems very clear to me that it was doctored from several runs, some of which were after the chosen skid path was completely run down by numerous tries. Let's leave aside the question of whether Rivian should have advertised this feature or not. More interesting is the Cybertruck's tank turn, which is achieved through diamond steering. I'll start by saying that I have no info or even a rumor regarding this. I'm just assuming things based on how I would have configured the Cybertruck had I been part of Tesla's team. What I'll say here could be dead wrong. It could be inaccurate or just the ramblings of a madman. Shout out to Tom Nash. But I do think I'm right. Remember my saying that Rivian's main problem was that the wheels are all pointing straight, but the required spinning movement is in fact sideways to the wheels? With full independent control of each wheel's power, braking, and steering angle, Cybertruck could bring this sideways movement by doing what I call diamond steering. Let's stick to the clockwise tank turn shown in Rivian's demo. Just like with Rivian, both left side wheels spin forward, and both wheels on the right drive in reverse. However, unlike Rivian, Cybertruck can steer each wheel independently, so should have no problem pointing both front wheels inward and both rear wheels outward, forming a diamond-like shape. This neatly produces the sideways force needed to spin the truck in a tank turn around its center of mass. Looking at my sketch, I'm sure many of you will call foul, as there's no way to steer the rear wheels and possibly even the front ones to angles large enough to circle around the center of mass. From a pure geometric point of view, anyone arguing that would be right. But the beauty of it is that even small steering angles would be enough. When a powered wheel is steered, the forward force is a function of the sine of the steering angle, and the side force a function of the cosine. Since cosines grow rapidly with the angle, even small steering angles are enough to produce a significant sidewards force that would help spin the truck. Because of that, steering the rear wheels as outwards as possible and steering the front wheels inwards based on that angle should be enough to supply low-speed, controllable tank turns that Rivian has no chance of producing. And since the wheels are at an angle, they could resist drifting down slopes. It's a fine balancing act for the AI, but not too hard and definitely possible. In short, if my assumptions are true, Elon was not kidding when he said that Cybertruck's technology would be insane. Just look at this grocery list. Electrically assisted brake-by-wire independently braking each wheel. Electrically assisted steer-by-wire independently steering each wheel. Quad motors independently powering each wheel. A kneel-down function making a rear step redundant. A built-in tailgate ramp making loading bikes and ATVs a breeze. Yoke control with variable ratio steering. Rear wheel steering. Torque vectoring. Crab walk. Low-speed tank turn. Diamond steering. And so many other things I haven't thought of, which Tesla engineers have waiting for us. All this, and we haven't even touched the hidden gems found in the design, the production method, the steel, the glass, etc., which I'll touch on in the next video. I promise not to bore you with stuff you already know and to focus on new points that few of you are aware of. To get a heads up once that video is out, make sure to subscribe and hit the bell notification button. Until the next video is out, let me know below what you think. Which features do you think Cybertruck will have, and which are just a pipe dream? Which would you prefer to own, a Rivian, a Hummer EV, or a Cybertruck? Did you order a Cybertruck, or maybe more? And how anxious are you to see one in person, on the road? I myself can't wait, but let me know about you. I read all your comments. If you liked this video, please give it a thumbs up to help with the YouTube algorithm, and consider sharing it on social media to help get more reach. Also, consider buying me a beer on PayPal or supporting me on Patreon for as low as $1 a month. It'll really help me invest more time so I can deliver quality content faster. So if you want to support the channel and get access to my exclusive patron-only newsletter, you can head over to patreon.com, and together we can make this channel grow. A huge shout out to my latest patrons, Will Tinsley, Mick N., Jordan, and Tony Betts. And to all my patrons, you guys rock. You can follow me on Twitter, where I am connecting no dots. And until next time, I am connecting the dots, and you are amazing.